Hi, I'm Bob. Welcome back to the solutions to the exercises for the textbook Microeconomics Theory and Applications with Calculus, the 5th edition by Professor Jeffrey Perloff. Today, we will solve the problems for the Monopoly Market Power and Welfare section in Chapter 11. Here's exercise 2.1. Under what circumstances does a monopoly set its price equal to its marginal cost? We use the monopoly's price-marginal cost ratio formula. As the elasticity of demand, epsilon, approaches infinity, the ratio approaches 1. It implies that if the demand is highly elastic, the monopoly will set its price very close to its marginal cost. The monopoly will behave like a competitive firm. Let's solve exercise 2.2. We know the product's price and its marginal cost. What is the firm's Lerner index? What elasticity of demand did the firm face if it was engaging in short-run profit maximization? We plug the price and the marginal cost into the Lerner index definition. It is approximately equal to 0.998. It is close to 1, indicating the firm has a strong market power to set the price much higher than its marginal cost. Using the relationship between the Lerner index and the demand elasticity, we obtain epsilon equal to minus 1.0016. The demand curve the firm faces is only slightly elastic. Let's find answers to exercise 2.3. We know the stam's marginal cost and the price. What is the firm's Lerner index? If it is a profit-maximizing monopoly, what elasticity of demand does it face for a customized stamp? We put the price and the marginal cost into the Lerner index measure. It is 0.58. If the firm is a profit-maximizing monopoly, we have the relationship between the Lerner index and the demand elasticity. We can calculate the epsilon, minus 1.71. Let's go to exercise 2.4. When the iPod was introduced, Apple's constant marginal cost of producing its top-of-the-line iPod was $200, and its fixed cost was approximately $736 million. The inverse demand function is as follows. What was Apple's average cost function? Assuming that Apple was maximizing short-run monopoly profit, what was its marginal revenue function? What were its profit-maximizing price and quantity, profit, and Lerner index? What was the elasticity of demand at the profit-maximizing level? Show Apple's profit-maximizing solution in a figure. Since we have the marginal cost and the fixed cost, we can write the total cost function and the average cost function. Then we can write the firm's revenue function from the demand it faces. R equals P times Q. taking the first derivative gives the marginal revenue MR. If the firm maximizes its short-run monopoly profit, it sets its output Q star such that the marginal revenue equals the marginal cost at that quantity. Solving the equation gives the monopoly quantity of 8 million and the monopoly price of $400. Now we can calculate the total revenue and the total cost. The profit pi star is the difference between them. It is $464 million. The Lerner index is 0.5. Using the relationship between the Lerner index and the demand elasticity at the profit maximizing level, we obtain the epsilon minus 2. As the graph shows, the monopoly optimum is E. The intersection between the marginal revenue and the marginal cost curves determines the quantity, and then the inverse demand curve determines the price. Let's see exercise 2.5. In 2015, Apple introduced the Apple Watch. Suppose the marginal cost was $84 and its price was $349. What was Apple's price marginal cost ratio? What was its Lerner index? If Apple is a short-run profit maximizing monopoly, what elasticity of demand did Apple believe it faced? We plug in the price and the marginal cost and find the price marginal cost ratio. We then calculate the Lerner index. If Apple is a short-run profit maximizing monopoly, it sets output such that marginal revenue equals marginal cost at that output level. And we will have the relationship between the monopoly market power and the demand elasticity. We can solve for the demand elasticity. Let's go to exercise 2.6. Draw an example of a monopoly with a linear demand curve and a constant marginal cost curve. We show the profit maximizing price P star and output Q star in part A. Q star is determined by the intersection between the linear marginal revenue curve and the horizontal marginal cost curve. We then find the P star from the inverse demand curve. The monopoly optimum is E. The consumer surplus is the difference between the amount consumers are willing to pay and what they actually pay. It is the blue area. The firm's producer surplus equals the difference between its revenue and its variable cost. It is the red area. If the monopoly were to act like a price taker, the price equals its marginal cost. It will sell QC outputs. In this situation, the consumer surplus is the sum of the blue, red, and yellow areas. The producer surplus is 0. The welfare is the sum of consumer surplus and producer surplus. Compared to the competitive case, the welfare loss is the yellow area, which is the deadweight loss. We summarize the results in the table. In part B, suppose the demand curve D2 is concave to the origin and tangent to D1. It is uncertain whether the new monopoly optimum is still E1, because the new marginal revenue curve may not intersect the marginal cost curve at the same place. Assuming the new monopoly optimal is still E1. The consumer surplus is the blue area and the producer surplus is the red area in the monopoly case. If it acts like a price ticker, the new competitive quantity is Q2, which is smaller than QC. The consumer surplus is the sum of all three areas. The deadweight loss is the yellow area under monopoly. In Part C, the new demand curve D3 is convex to the origin and tangent to D1. Suppose the new monopoly optimum is still E1. We can find similar results. The competitive quantity is Q3. Let's solve exercise 2.7. Suppose that many similar price-taking consumers, such as Dennis in Chapter 10, has a single good, candy bars. Jane has a monopoly in wood, so she can set prices. Assume that no production is possible. Using an Edgeworth box, illustrate the monopoly optimum and show that it does not lie on the contract curve, that is, it isn't Pareto efficient. We draw the Edgeworth box. The initial endowment is E, where J owns 50 units of wood but 0 candy, while Dennis owns 80 units of candy but 0 wood. Under a monopoly in wood, the wood's relative price is high and the price line is flat. J wants to trade to bundle J, and Dennis wants to trade to bundle D. J wants to buy 70 candies, but Dennis only wants to sell 10 units. Dennis wants to buy 5 units of wood, but J wants to sell 10 units. There will be a shortage of candy but a surplus of wood. If it is a competitive market, the relative price of wood will drop, and the price line will become steeper. A competitive equilibrium will be achieved, at which the two consumers' marginal rate of substitution will be the same. Only the competitive equilibrium is Pareto efficient and on the contract curve. Under a monopoly, however, the price has been set, and the competitive equilibrium cannot be achieved. Thank you so much for doing all the exercises with me today. See you tomorrow. Take care. Thank you for watching this video and subscribing to my YouTube channel. See you next time.